Hello and welcome back. Today we'll be doing question 5 from the 2017 STEP Paper 3. This is a question about perpendicular polar equations and differential equations. So, let's get started. Question 5. The point with Cartesian coordinates x, y lies on a curve with polar equation r is equal to f of theta. Find an expression for dy by dx in terms of f of theta, f primed of theta, and tangent of theta. Two curves with polar equations r equals f of theta and r equals g of theta meet at right angles. Show that where they meet, f primed of theta, g primed of theta, plus f of theta, g of theta is equal to 0. The curve C has polar equation r is equal to f of theta and passes through the point given by r is equal to 4. Theta is equal to negative 1/2 of pi. For each positive value of a, the curve with polar equation r is equal to a of 1 plus sine theta meets C at right angles. Find f of theta. Sketch on a single diagram the three curves with polar equations r is equal to 1 plus sine theta, r is equal to 4 of 1 plus sine theta, and r is equal to f of theta. Pause the video now to have a think, and once you're ready, restart to see if you were correct. Let's get started. Firstly, we'll write dy by dx as dy by d theta divided by dx by d theta by the chain rule. Here on the right, we'll write x is equal to r cosine theta, which is equal to f cosine theta, where f is the shorthand notation for f of theta. We therefore have dx by d theta is equal to f prime cosine theta, take f sine theta. Similarly, we write y is equal to f sine theta, and therefore dy by d theta is equal to f prime sine theta plus f cosine theta. Now, back on the left, we have dy by dx is equal to f prime sine theta plus f cosine theta, all over f prime cosine theta take f sine theta. Dividing through by cosine theta, we end up with f prime tangent theta plus f, all over f prime take away f tangent theta. We can now move on to the next part of the question. Here we have that f and g are perpendicular, and therefore their gradients must multiply to give negative 1. Substituting f and g in, we have f prime tangent theta plus f over f prime take f tangent theta multiplied by g prime tangent theta plus g, all over g prime take g tangent theta is equal to negative 1. Multiplying out and then simplifying somewhat, we have that f prime g prime tangent squared theta plus fg plus f prime g prime plus fg tangent squared theta, all over f prime g prime take f prime g tangent theta take fg prime tangent theta plus fg tangent squared theta, all take away 1 is equal to negative 1, and therefore, because denominators cannot be 0, we have that the numerator must be equal to 0. The numerator simplifies down to f prime g prime secant squared theta plus fg secant squared theta, which is equal to 0, and dividing through by secant squared, which is never 0, we have f prime g prime plus fg is equal to 0, as required. Now we can move on to the last part of the question. Here we will set g of theta to be a of 1 plus sine theta, and therefore we have that g prime is equal to a cosine theta. We will now substitute g and g prime into the equation found just before to get a cosine theta of f prime plus a 1 plus sine theta of f is equal to 0, and we will rearrange this to have f prime plus 1 plus sine theta over cosine theta of f is equal to 0. Now we will find the integrating factor, I, which is equal to e to the integral of 1 plus sine theta over cosine theta d theta. Evaluating the integral gives the natural log of secant theta plus tangent theta take away the natural log of cosine theta, and this means that the integrating factor simplifies down to 1 plus sine theta all over cosine squared theta. Using this integrating factor, we can now find f, which is equal to 1 over the integrating factor multiplied by the integral of 0 multiplied by the integrating factor with respect to theta. This simplifies down to k cosine squared theta over 1 plus sine theta. Expanding cosine squared theta out as 1 plus sine theta, 1 minus sine theta, f will eventually simplify down to k of 1 take away sine theta. From here, using the given point of theta equals negative pi over 2 and r equals f equals 4, we have that k is equal to 2, and then f of theta is equal to 2 of 1 minus sine theta. Finally, we can plot all of these graphs separately on the same axes. The red is 1 plus sine theta, the blue is 4 of 1 plus sine theta, and the green is 2 of 1 minus sine theta. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.